Okay, so let's talk about orthographic projection and what that actually is. So orthographic projection is effectively, it is 2D flat drawings that represent different views of a 3D object. And the reason that we have this style of drawing is because when we render something in 3D, that gives us a really good idea of what something will look like in real life. But as a manufacturer, if I've designed a product and I want to send those plans off to another company and I want them to make that product exactly right, to the right size, with all the right angles, all the right measurements in all the right places, then actually I need to send what we would call a technical drawing. And that technical drawing needs to include measurements, and it needs to show exactly where all of the different areas correlate and work together. And actually the most accurate way to do that is with 2D flat drawings that show each angle. In other words, a top view, this is what this object would look like if you were looking straight down. This is what the object would look like if you were standing here and looking straight at it. So you would see that bit there, and then you would see this back bit there. And this is what it would look like if you were looking at this side here. And by sending these drawings with the measurements, a manufacturer is able to accurately recreate those products. This is for technical specification, but you can also use orthographic in your initial ideas just to show different views of an idea or a concept. Here's an example then of that actual project if you were drawing it orthographic. So you can see here how they line up. So we've got the front view, and then we can see here how this bit lines up exactly with that bit. So the bottom of the object and the top of the object are the exact same height, and they all line up. And just like here, this bit here represents this bit here. And so you can just see how creating a technical drawing like this can really help you understand what the measurements are and how something looks. Now, I appreciate that's quite difficult to maybe get your head around, so let me show you with a 3D object. Let's imagine this is our toy that we've been designing, or it's a product that we've been designing. Here it is in 3D, and I can rotate around this and I can look at it. Here is my product in 3D. Now, an orthographic projection would look like this. If I go to the front view, you can now see it is completely flat, but I know the height of it, and I know the width of it, and I know each of these parts, where the shoulder is, where the leg is. The side view will give me more information. So the side view tells me the depth of the head, the depth of these objects here. And then finally, I can do a top view. And the top view again shows me what this will look like from the top looking down. Because there might be bits that stick out. In this case, there aren't. Now for orthographic, they're the three main views that you would do, but you can actually have lots of views. You could go underneath on the bottom. You could do the other side. If this side was different, for example, if this arm was in a different position, you could show more than one view. But effectively, that's all an orthographic projection is. It's where you have a 3D object like this, and you show it by using 2D drawings of each view. So the top, the side, and the front.